In this episode, we discuss the use of container technology for building industrial IoT applications. My guest on this episode is Neil Cresswell. Neil is the CEO and co-founder of a company called Portainer, which provides a container management system that simplifies container operations, allowing you to deliver containerized applications from the data center to the edge. Prior to co-founding Portainer, Neil has been CEO and CTO of multiple companies in the cloud computing space, and he has worked as an IT architect for IBM Global Services. A quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade edge and cloud-based MQTT broker. So please do check them out to help support this podcast. Welcome to the Fourth Generation podcast here on Industry4.tv, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So if you're new here, please make sure to subscribe and click on the notification bell so that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and you can also connect with me on LinkedIn at Kudzai Manditereza. Okay, so Neil, it's great to have you on the show today. Thanks for coming through.
Thanks for inviting me. Can't wait to talk about all the cool things around Industry 4 and containers and Portainer.
Awesome. Yeah, so today I would like to talk to you about containerization, particularly in the context of industrial IoT. Mm-hmm. So now to begin, a huge portion of our audience here are industrial engineers. And as you would know, containers are relatively new to the industrial automation world. So maybe you could start by explaining to the audience what containers are and how they work.
Sure. Well, containers get their name a little bit. They're kind of riffing off shipping container analogies because the whole concept of a container in a shipping container speak is it is a completely safe, secure way to encapsulate a packet of something. Could be tires, could be food, could be chemicals, package them up securely and ship them anywhere in the world in a very standardized, repeatable, predictable way. Every single ship, every single truck is standardized on shipping container footprint and format. You can ship a shipping container anywhere in the world and it'll be transported in exactly the same way. So containers, riff off or play off that analogy with software. So containers in a software speak are a way to take a piece of application code or application functionality, package it in such a way that it is 100% portable and can run anywhere on any system in the world. So a containerized application runs on my PC. It can run in a data center. It can run in a cloud service. It can run on a PLC. It can run on an industrial PC. And it runs in exactly the same way every single time because it is a completely portable construct for an application. And it is, because of that very nature, it is the way now that application vendors are shipping their software because it is so predictable, so easy to support, and so easy to maintain. Does that help explain things?
Yeah, absolutely. So maybe now that we understand what containers are all about, what would you say are the benefits of containerization, particularly in factory floor situations or in the industrial edge?
So containers are a really interesting piece of technology because they provide isolation between themselves. You can have on a piece of hardware, you can run a container runtime environment like Docker or Podman or something else. And in that environment, you can run a multitude of applications, and each application is completely isolated from each other and from the underlying operating system. So it's a really safe and secure way to run applications on remote devices. Now, if you think about OT type environments, a lot of the time I would describe them like an egg. They've got a very strong outer shell, a firewall, but once you're in the OT network, you've pretty much got freedom of movement inside that OT network. And that's scary for a number of reasons. If your application is compromised and someone managed to get inside the OT network through piggybacking off that application, they've got free reign across that entire network pretty much. And if I don't know if you've just seen the news came out regarding the new malware pipe dream, which is infecting the CodeSys runtime that most of the PLC vendors use. And it's a backdoor and allows hackers into your OT network through CodeSys. A prime example, if CodeSys was running in a container, it is encapsulated and secured and controlled and governed. So, the primary benefit is around isolation, security, encapsulation, control. The second benefit is around ease of update. So if you have a containerized application running out there on the factory floor, you can update that in a very, very simple way. And if the update fails, rolling back to the previous version, it takes seconds. So in regards to updates, you're minimizing the risk of updates because you can update fast and you can fail back fast should you need. So they're the two main benefits. I think the final benefit, and by the way, there's dozens of benefits, but the top three would be centralization of control. So you can actually have a centralized control plane or a centralized manager managing potentially hundreds and hundreds or thousands of shop floor type environments, managing the container environments on them all, and centrally deploying, managing, updating all those applications that are running.
So now I want to focus more on the industrial edge here. So as I've already alluded to at the beginning of this session, that one of the challenges with containers in industrial facilities is the small number of people who understand and how to work with this stuff. So what would you say are other challenges, technical or otherwise, for implementing containers in industrial facilities?
Well, containerization is an IT technology, right? It is. And not only is it an IT technology, it's an advanced IT technology. Yeah, if you ignore OT for a second and just say, corporate data centers, inside corporate IT, containers can only really be managed by a subset of legacy IT people, right? So it's not just an IT principle or technology that anyone can use. It's an advanced IT principle brought into OT. Now, OT engineers are very, very good at OT engineering. They don't necessarily have the same exposure to IT technologies, let alone advanced IT technologies like containers. So the uphill learning curve for containers might be quite high. It's very, very command line driven. You can drive it from the command line, configure everything. You drive it from APIs, and or you drive it from code. So if you don't know how to SSH into a host and run command line instructions or write code to control it, the learning curve is almost like a wall as opposed to a nice steep ramp. And that's where Portainer comes in. But so there's that. The second thing is, if you're used to installing applications on like a Windowsy PC and managing your PLCs or managing your control systems from a Windows PC directly connected, then that's quite different. The whole containerization is very different. You're connecting to the physical device, running instructions on the device that's controlling Docker directly. So it's quite different in that regard. So it has huge benefits, but it's quite difficult to get started, and that's why there are products like Portainer coming out to say, well, hang on, let's try and abstract away as much of the IT complexity and make this technology available to OT engineers in a real, clicky, web-based UI that feels familiar.
All right. So maybe to help us clarify this, could you highlight what are the key differences between containerization in the cloud and containerization at the edge? Like, what would you say are the key differences that you could highlight there?
So Docker and its other ancillary products like orchestration, Kubernetes, other things like this, they were all designed for the data center. They really were, and they're now being morphed or repurposed, reused, expanded, call it what you like, into the OT network, so into Industry 4 shop floor. But they right from day one, they're built for the data center. So ingrained in the product, its natural behaviors, it expects a data center. It expects internet access. It expects reliable internet access. It expects that there are security controls that are managing and governing it. It expects a whole bunch of stuff that is commonplace inside the data center, but is not so commonplace inside industry floor, shop floor edge. And so there's a bunch of configuration changes you need to make to get Docker and Kubernetes to work reliably at the edge. And there's a whole bunch of organizations that are working on making that easier by having it pre-configured to work optimally on the shop floor. Products like Portainer, as an example. So Portainer takes the Docker runtime, modifies it so it works better on the shop floor, and that's a nice reliable way of doing it. So there are differences. For example, just things like the Docker pull command, which is how you get container images onto the device. It expects to be able to pull that from a public registry sitting on the internet. Now, there is no way that anyone in OT is going to allow their PLC connected to their factory floor to go and pull a random image off the internet to run a container. There's just no way. So you have to think about, well, hang on, how am I going to get access to that? Especially because even in the most, flexible or open network, the OT network is isolated from the IT network. It has to go through gateways. Those gateways don't route. They might proxy if you're lucky. So how do you get an image from a public repo that's either on the IT network or further afield? How do you get that image into a relatively isolated OT network? And out of the box, Docker and Kubernetes aren't designed to do that. And so you have to make modifications to accommodate. So there are quite a few differences.
Okay. And then maybe when it comes to the issue of compute resources, would you say that is a factor? Is that a contributing factor? Is like because typically in the industrial shop floor, you'd have devices that have got like really limited amount of resource, computationally speaking. Is that a factor at all as with regards to running containers?
It is. Docker and Kubernetes expects to be running on big fat old servers sitting in a data center. Multiple CPUs, multiple gigabytes of RAM, if not terabytes of RAM. And so when you try and fit that square peg into a round hole, things go crazy. Now, a product like Docker, it's quite efficient. There's about 100 megabytes of memory overhead to run Docker. So it's completely feasible to take a PLC with a single ARM CPU, 1 gig of RAM, or even 512 meg of RAM, and run a Linux operating system, install a Docker runtime, and do things like a ePLC or a soft PLC and Node-RED and an MQTT piece of software on the device using Docker. That's completely feasible. If you try and use something like Kubernetes on those same devices, you're in for a world of pain, because to even idle something like Kubernetes needs about 500 to 600 meg of memory. Just to idle, to do anything, you've got to have north of 1 gig. I actually just published a blog recently where I took a bunch of devices with 1 CPU, 1 gig of RAM, installed Kubernetes on them and tried to deploy just one application, and it failed. So really, if you've got under 1 gig of RAM, there's no feasible way with any of the micro Kubernetes distributions today to run it on that type of hardware. So you're really limited to Docker. So yes, obviously hardware footprint plays a big part there. If you've got more than 4 gig of RAM on your device, you've got a bit more flexibility. But if you're constrained, and most PLCs are constrained, then you really are talking about Docker, not Kubernetes.
So one architectural approach for building industrial IoT solutions that is enforced by using containers is the microservices architecture. And again, this is a new kind of architecture when it comes to industrial automation. It's been around in IT for some time, but when it comes to the industrial automation space, that's also a new phenomenon. Maybe can you start by giving us a description of what microservices are and explain to us how they could be leveraged for industrial IoT?
So microservices are not a prerequisite to use IoT in Industry 4. Microservices are a way of architecting an application. Now, microservices does not mandate the use of containers at the edge. You can use microservices with functions and other technologies. Microservices is a way of architecting your application so that it is broken into discrete, smaller components. Like there might be a particular piece of functionality that controls just one sensor. And there's another piece of function that runs another sensor. There's another one that's running something else, another that's running else. So each of these would run as a separate container, and if you were to talk about it in container speak, so that you might say, well, actually, there's a bug in the software that's controlling my speed sensor. I'm going to fix that bug and redeploy it. So just that piece of the application is taken offline whilst it's being updated. The vibration sensor, the temperature sensor, the humidity sensors, these remain online because they are separate containers, separate elements of the application that are not changed. You're only changing this piece. So microservices lets you take your application, fragment it into a bunch of bits. That's so that you can actually maintain those bits in isolation, which again says, well, I'm actually going to only take down a small piece of it while I update this. So it gives you that kind of flexibility. You don't have to do microservices to do containers at the edge. You can have a single container that's running MQTT, a single container that's running a pass-through database, a single container that's running a soft PLC. That's not microservices, but they still run in containers. So you can do containers with microservices applications, or even microservices without containers. So they're all, they're different technologies. Combined, they're very powerful, but you don't have to run them combined.
Now, let's move on to Portainer, which is the most popular container management platform in the world, developed by a company for which you are the CEO and co-founder. And I must say you've done quite some excellent work building this and putting it out there.
Thank you.
Can you tell us what is Portainer and give us an overview of how it works?
Yeah, I describe it many different ways to many different people, and it really depends how the best way it would resonate for you. The whole principle behind Portainer is to humanize the technology as much as possible. As I said at the start, containers are an IT concept, and only a subset of IT engineers can grasp the concepts behind containerization. And right from day one, I believe that wasn't fair. If only a subset of people can enhance their careers because they have the ability to comprehend and reskill themselves with containers, why should they be left behind? We should be able to bring everyone in IT who wants to on the journey to understand how containers work. And then at a higher level, if only the largest of companies can afford to go and hire or train staff who understand how to drive containers, then other organizations who can't get left behind. And I thought that's not fair. This technology is such a transformational piece of technology. Every single company of any kind of financial viability or maturity, regardless of where they are in the journey, should be able to adopt and embrace containerization technologies. We should be able to make that available to them in a way that their internal IT teams can comprehend and support. And so that's what made us successful. Because of this humanization layer and taking away a lot of the complexity from the tech, organically, it's appealed to OT engineers, because OT engineers kind of fit into that same camp. OT engineers, I don't think many would claim to be IT experts. They're two very different techs. And so because Portainer is a tool that's designed to take away the need for an IT expert, so to speak, an OT engineer will log into Portainer and find Portainer quite easy to use, and will let them do some very advanced things without necessarily knowing what's happening behind the scenes. So it's kind of really helped in that regard. So Portainer is a tool that humanizes the technology. It abstracts away complexity without compromising on capability.
Oh, okay. So, well, correct me if I'm wrong. So does it mean without Portainer, for you to be able to manage your containers, you would have to understand something like Kubernetes? Like you have to understand
100%.
Yeah.
100%. Without Portainer, your ability to get going with containers, you're going to have to send your people on training courses to learn Docker, to learn Kubernetes, to learn how to manage containers and applications. Containers are not virtual machines. Containers are not servers. They're managed in a different way. You troubleshoot in a different way. You performance monitor them in a different way. You update them in a different way. Any skills you might have in server management are not 100% transportable to managing containers. You have to relearn what you knew here. And for an OT engineer who's familiar with PLCs and programming, they're very different. So the relearning required there would be dramatic. And so without Portainer, you'd have no choice but to go and put your people on long training courses, spend the time and money and effort to get them retrained so they understand the platform, and then by the way, retain them, because these people are in high demand. So and then retain them. Whereas Portainer takes it away and says, any OT engineer should be able to log into Portainer and do some really cool advanced stuff without knowing necessarily the underlying tech.
Now, when it comes to industrial IoT or Industry 4.0, are there any use cases for Portainer that you could share with us?
I can't share names because most of these companies have us under NDAs, but I can definitely share use cases. We are used a lot on the shop floor where organizations are moving from legacy SCADA and they are investing in new MES software, and the MES software provider is making their software available as a container. If you think back to the very start, right, I said containers are an amazing way to ship software. It makes it really easy to ship software. It makes it very easy for the vendor of the software to support it and update it and maintain it. And so every vendor on this planet, every company who's writing software is now preferring to write it and ship it as containers because it makes their life much easier. Well, that's cool. But you're a factory floor. You're a factory. You're manufacturing something. Your vendor now says to you, "Hey, our new MES, here it is. Here it ships as Kubernetes," and you're like, "Kuba what? what are you talking about?" So for them it makes sense. For you, not so much. And so when you get the software from your MES provider, how do you run this in your factory floor data center or comms rooms? How do you distribute the software that has to run inside the cabinets on the actual production floor? How do you do that? So Portainer is used in that regards for a number of organizations where they have a central instance of Portainer that's managed by OT engineering. There is a copy of Portainer running a small cluster of Docker environments that might be in a particular factory. And then in the cabinets on each production line, there are PLCs or industrial PCs running Docker, running containers that's collecting sensor data and shipping it back to the MES provider. And Portainer manages all of that at that level. And this is across the board in pretty much any kind of production facility you can imagine. If you have software running centrally, software running that out at each production line that's controlling robots, sensors, machinery, facilities, and pulling data back, then that's where Portainer works. We also work outside of that in smart building control, where you want to run. Again, it's very similar concept. You've got a building, you've got industrial PCs running in the building, controlling things like lighting and temperature, humidity, windows, all that kind of stuff. So there's lots and lots of examples there. Also, predictive failure. So if you have vibration sensors that are running, if you're doing kind of retrofit kits on your existing shop floor machinery, and you've got a separate parallel network, you might have retrofit kits there. You've got sensors running, collecting data, feeding them back to an AI engine that's determining, hey, this machinery is getting abnormal vibrations. There's probably something going to fail. Again, that's where Portainer is used as well. So a lot of use cases in factory floor, a lot of use cases in smart cities, smart buildings. Yeah.
Oh yeah, sure. That sounds really interesting. Now, when it comes to like your product offering? What options are there for Portainer?
So Portainer is, as a company, is what's known as commercial open source. So we have a version of Portainer that is freely available, completely open source, unsupported open source product. Anyone can get that and deploy it. I've got to be honest, a lot of the PLC vendors who support Docker now ship Portainer or make Portainer available through their web UI. So if you log into most of these, like we've just partnered up with Wago as an example, and if you log into the Wago web UI, there's a button to say enable Docker. When you enable Docker, it automatically deploys Docker and deploys Portainer for you, so you can manage it. But Phoenix Contact, Weidmuller, others, there's a lot of these other vendors who, as part of their firmware, ship Docker, ship Portainer, the open source community edition, just because it's so easy to use. Outside of that community edition, we have Portainer Business, which is our fully supported closed source proprietary version. In that version, we add substantially more capability around security and compliance, as well as adding professional support as well. So if you're running this in your shop floor and it is a mission critical environment, it is recommended to use the paid edition versus the free open source edition. Not only do you get support, but you also get additional security compliance like MTLS and other capability.
So now to move on, so as I'd mentioned earlier, we've got like engineers and architects here who might be wondering right now to say, is there some kind of reference architecture for managing software in OT using containers that you could maybe you could provide insights on that?
Yeah, we've actually just launched a new micro website within the Portainer IO main website. So on our homepage, there's a button that you can click to take you to IoT. And inside there, we've actually published 2 reference architectures that we see the most common. And then off those 2 reference architectures, we give detailed instructions about how they work, the benefits, the limitations. We're going to be publishing a lot more specific instruction for those 2. So almost like a POC setup guide. So if you want to deploy and try either of those 2 architectures, here are the steps that you go through. And really it boils down to, is your OT network isolated, or does your OT network have the ability to reach out and touch the internet? They're really the 2 most common use cases. If your OT network is isolated, then things get a bit more complicated. You need to make a few more adjustments to accommodate containers working well. If your OT network has the ability to reach out to the internet, then things are a bit easier. And so we've got these 2 architectures, which show you in that regards. Oh, also, very, very happy to workshop with organizations as well. If there's organizations who are looking to undertake a Industry 4 transformation and want to whiteboard and workshop, we're more than happy to share our skills and experiences too.
So yeah, we've spoken at length about containers and Portainer, and maybe from your experience, are there some best practices that you would say really stand out for you with regards to working with containers, particularly in the industrial domain?
I think the main one is security. Containers let you run applications, and you need to be very, very, very careful, because when you're running an application in a container, you're running it from what's known as an image, and an image comes from a container registry, which is basically just a web server that holds an image file. There's actually a lot of hostile actors who are taking into account that humans make mistakes, and a lot of us spell terribly. And you can take some of the most common container images, like if you took mosquito as an example, a lot of people don't know how to spell mosquito, and hackers are publishing hostile images with the most common spelling mistakes for the real mosquito image. And so it is beholden on you to ensure that you configure your environment in such a way to protect yourself from this kind of human error or malicious intent. There are configuration options you can make to say, only allow my environment to run images that come from my trusted environment. Don't let any random image be pulled and deployed in my environment. So there's a real onus on the OT engineer or whoever's responsible for running this Industry 4 project to correctly secure the environment. If you don't, and an engineer makes a typo and pulls an image, and it happens to be one of the hostile images that's been brand piggybacked. As I said, normally when you're on that OT network, you've got free reign, so be careful. And there's definitely a lot of people on the warpath to try and get into OT networks. So there's that. Also, Docker and Kubernetes, they kind of expect you to know what you're doing. If you don't know, like they're very customizable. They're very powerful. You can do anything you like, and they expect you to know what you're doing. And if you don't know what you're doing, you can get yourself in trouble real quick. And so you either need a tool like Portainer that takes care of that for you, so it protects you from yourself, or if you don't, be super careful that you spend the time to learn the tech. It's very, very dangerous to spend 5 minutes on Google and say, I've got this, and deploy, get an application up running. It'll get up and running, absolutely, but it'll be insecure. The platform will be completely vulnerable. It's dangerous. So, don't let your own ego get in the way of safety and security. Realize this technology is quite different. Realize that by default, it's massively insecure. And so therefore it's easy to get something running, but it's running in a really dangerous, insecure way. So spend the time to either learn it or get a tool like Portainer that will do the best practice things for you.
Now, you have already highlighted that there's some breed of PLCs that are capable of running containers right now. And but looking into the future, I would imagine that most, if not all, PLCs are going to be container based. Can you give us insights into how a containerized PLC may function?
100%. I think that, right now, I'd say there's still a little bit of fear around putting your PLC. And again, there's a difference between the PLC software that controls the piece of hardware and the hardware's ability to run things like Docker, right? So that a lot of these vendors who are bringing Docker, the PLC software still runs in firmware, but alongside that, it also runs a copy of Docker, which can run containers. Okay, so that seems to be how most of these vendors are doing this. They've got the operating system installed on bare metal, the PLC software installed on the operating system, Docker installed on the operating system, and then containers. So the PLC itself is not containerized, other software is. And so now you can run ancillary software like Node-RED and other capabilities on the device, talking loop back to the PLC software to control devices. So that's quite commonplace now for a first step. A second step, which is what companies like Revolution Pi are doing, where they're taking industrialized Raspberry Pis. They are actually running the PLC as a software container, a soft PLC, ePLC, call it what you like. Now that's a bit radical, and you'd have to have a pretty open mind to accept that, because it's still quite early days. And that will that become more mainstream? I see no reason why it would not. Like, for example, this pipe dream malware that's currently infecting Schneider and other PLC vendors. If that was running as a container and a patch was made available, you could push out that patch. If it was running as a container, you could push out that patch to all of your environments and have them all updating the new version of the container in a very short space of time. Because it's firmware, an engineer is going to have to go to every single PLC and do a firmware update on that PLC. That's going to take a very, very long time. So, the same benefits why software vendors are shipping their software as containers, same thing applies for PLC vendor software as well. It's far easier to maintain and control and update and everything else. So I think it's not if, it's when everyone switches to having container-based PLC software.
Well, it sounds like this advent of containers affects not only just the engineers who get to work with this stuff at the factory floor, like in-house engineers, but also system integrators as well. What sort of impact do you think containers would have in the system integration business?
Well, no one just deploys containerization. You don't just wake up in the morning and say, hey, I'm going to go deploy my factory floor in containers. You don't do that, right? There's a whole project to make a change from, say, a traditional SCADA type environment to an Industry 4. And that has an entire project team, it has architects, it has system integrators, and it has an ongoing support element. Docker itself needs to be updated. The platform has to be updated, it has to be maintained, it has to be supported. And so from a system integrator perspective, they have the ability now to offer new managed services around managing the whole containerization layer, and helping organizations with OT engineers who don't want to manage containers to say, actually, we're going to manage it on your behalf. So there's a whole new managed service business that's going to spring up around this. It also really does open the door to a lot more IT-centric applications reaching down into the OT world. If you take, for an example, video streaming, video streaming is a piece of software that really exists in the data center. You've got head-end ingesters that are ingesting a live stream. They're doing transcoding and sending that stream to somebody else. That's a real data center piece of technology. Well, in Industry 4, there's this amazing thing called third eye, where an engineer can wear a pair of VR goggles, or it's actually augmented reality goggles, that has a camera. And so the camera is taking a live feed of what the engineer is seeing. The engineer is seeing what they're seeing, as well as a transposed computer display, feeding back to through some kind of live streaming transcoding engine, feeding back to a level 3, level 4 engineer somewhere else, somewhere in the world. So if you think about emerging markets that might struggle with some really advanced engineering concepts, they might be able to now be supported by software vendors, system integrators on the other side of the world using this kind of third eye technology. So it really does allow system integrators from America to now offer Industry 4 support services in Middle East, Africa, Asia, countries that are potentially still developing and don't have the same level of OT engineering expertise. So, and because you can bring IT software down into the OT space.
Oh yeah, that's really interesting. I always say to system integrators that this new technology, like for example containers, it's something that you can't ignore, because it attracts a new breed of system integrators, people who would otherwise not be interested in industrial automation, but because now there's this cool technology like you just described, you've got containers, it's now attracting a new breed of system integrators who are crossing over from IT into this space. So just maybe as a comment, I would say this is a call to system integrators to try and learn this stuff, because it's not going away. That's my opinion, actually.
Yeah, it's not going away. It's actually the underlying technology is actually great fun to play with and learn. Like it's incredibly flexible, incredibly powerful, and so as a result, it opens up massive opportunities for optimizations, efficiencies in the OT network in Industry 4. It truly does. There is a massive array of software built for the data center that's now portable through the benefits of containers to be run inside the Industry 4 networking space. And that's amazing, because Industry 4 or the shop floor has been proprietary for so long with a very select group of software vendors. Well, now that's cracked wide open. Now there's software vendors from wide ranging fields now can now offer capability. Medtech is another huge one. Obviously there's medtech has been very closed loop proprietary, and now you can run containers in the operating theaters, and you're doing all sorts of stuff, collecting patient data, sensors, and doing a whole bunch of smart analytics to help a surgeon to be a better surgeon. There's some really cool stuff in medtech. So it's just cracked open the whole software market to every software vendor now. So it's amazing.
Yeah, I totally agree. So now, if you were to maybe make a prediction, or maybe just to share your insights here, what do you see as being the future of industrial software distribution?
So software distribution, 100% containers, 100%. It is by far the best way that we have had in at least my 25 years in IT to distribute software in a hyper predictable way. You know, one of the worst things with software was it works on my PC paradigm. You know, a developer or a software vendor cannot reproduce the fault that the customer is reporting. That was so frustrating for both the customer and the software vendor. The customer has a problem, the vendor cannot reproduce the problem. The vendor tries and tries and tries and hands up. It's not my problem. I can't help you any further. The customer is left unable to function. Containerization takes a lot of that away, because you can actually say to the customer, okay, well, give me your container image, pass it back to me. I'll run it. I'll run your software in my environment. I'm actually triaging your actual piece of running software because they're so portable. So it makes support way easier, and also the ability to run applications so much more predictable. As I said, I can run some software at my machine. I can pass you the file. You can run it on yours. Yours and mine will run exactly the same. You can then push it onto a PLC. You can put it on an ARM device, an Intel device, a PowerPC device, and it runs the same way. It's hyper predictable, hyper compliant, common, repeatable. All those kind of adjectives. It's the way to ship software.
Okay, interesting. Okay, so now to conclude this session, could you maybe share, tell us a bit more about Portainer, the company? Where are you based? When was the company founded, and so forth?
Yeah, we're 6 years old. We're a company founded out of Auckland, New Zealand, which is for most people the complete other side of the world from probably anyone that's listening to me talking here, if you can even understand my accent. We have grown now. We have an office in California. We have an office in Hanover in Germany. We have a CTO based out of Germany who is responsible for our Industry 4 business unit, who comes from that industry. So yeah, he is more than happy to sit and talk tech and wire up cabinets and do all sorts of cool stuff. We've got developers all around the world developing the software for us, and we have a real focus on both data center capability and Industry 4. We're taking a different approach. Rather than data center to edge, we're going edge to data center. So we're actually starting at the edge and saying, okay, what applications run at the edge, and how do we help people get their edge systems back up to the data center rather than the other way around? There's a lot of vendors who go data center to the edge, and they don't fully understand the constraints that an OT network imposes. And they've got these flawed assumptions, and it just causes frustrations. We're going the other way around. We're starting with the edge and coming back to the data center. So we are venture backed, so we're not going anywhere anytime soon.
Okay. So Neil, that brings us to the end of this session. Again, thank you so much for taking the time to come out onto the show to share your insights with the audience.
No problem. And if anyone has any questions, I'm very receptive to email. It's simply neil@portainer.io. So anyone can email me and I'll respond.
Okay, cool. Thank you.
Thank you.